So what's going to happen is we are going to create a bunch of crystals that are then going to be combined with this fluid sim and then turned into a VDB so that they will blend together seamlessly. VDBs are awesome. I don't know how people worked without them, and I'm very happy that they exist today. So first off, we need to create a spot in which we can copy onto points. And you'll see what I mean as we go along. I'm going to create a sphere. And the sphere is way too big. Also, we need it to be a polygon. And so I'm going to change the scale to 0.326 because that's just what I had made before and it seemed to work fine. And then I'm going to take the radius and I want to smush this down a bit in Y so that it's a bit more oblong. Something like that. So I'm going to do 0.3 and I'm going to up the frequency to 6. We don't need too much frequency. We just need enough to smooth this surface out. And then what I want to do is I want to clip it because we only want stuff going up. So now that cuts the bottom out. And I think I'm going to move it up just a bit more. So I'm going to take the origin of this clip and I'm going to move it to 0.05. So yeah, that just leaves us this bit here. And then I'm going to remesh it. And I'm going to make the target size 0.0151. And this is just to make sure that we really are getting an even distribution of points along this thing. So then I'm going to transform this. I'm going to translate it up. Just organize this a bit. And then I'm going to make sure that we can see that. So now, delete that. Move this back here. And so then I'm going to move this up to 1.73. So this gets it just beneath the surface. And so what's going to happen is these ice crystals are going to grow up and outward. And so we are going to do a few things here. First, I want it, and if you recall when we looked at that flip book before, the ice cubes or the crystals in the center were much taller than the ones on the outside. And to do that, we need to create a gradient that's whiter on the inside and darker on the outside, and we can use that to multiply the p-scale. And again, you'll see what I mean as we go along. So first I'm going to create a color, and I'm going to make this black. I'm going to make another one that's white. And what I'm going to do here, there's plenty of ways to do this, but since we aren't going to be changing this geometry at all, I can just say boop, delete that, delete non-selected. So then now I have a point there that I can do an attribute transfer. And then you can see here that if I do color, the blend or the distance threshold is too high, so I can take this, move it way down. So I'm just gonna make it, I'm gonna make it 0, and then I can change the blend width, and I'm gonna make this 0.22. And now you can see that I have this gradient from the center working on outward. I'm also going to change the max sample count to 10 just to make sure that this is blending in a nice gradient. You can't really see in the viewport, but it does change the results. So next, we need to create a facet, and the facet then gives us normals. If we do pre-compute normals. So now we can see them here. And so what's good about this is that we can take these normals, and when we scatter points onto this, then it's going to inherit the normals. So if we do scatter, you can see now these points have the normals. That's too many points though. We don't need that many. We only want about 50. That looks much better. And then I'm going to change the seed just to something that I had before. So 2.17. You don't have to change it. This is just to get it more consistent to what I had created before. So next what we're going to do is we're going to make a point wrangle. And we want to change the P scale of this according to the color that we have. So first off, we'll do the same thing we've done a billion times before. So P scale equals fit01 rand pt num min max. But then what we're going to do is we're going to do P scale times equals, and then we're going to do another fit01. And we know that our color is 0 and 1, so then we can, I found a good value here of just 0.6 and 1.5. Normally you can make a min and max for these as well, but I just found that those are good values. If you want to have a slider to be able to change them, by all means, do it up. I'm just going to have those hard-coded values. So then I found that 0.389 and 1.4 were good values for this. And so we can't really see anything yet. But we do see here that here's our P scale. So next, there's a few ways to go about this. There's a copy stamp, and then there's for each. I've used copy stamp before. I've found that it's much slower than for each. So we're going to do for each. And if you don't normally do this, this is a way to kind of dip your toes into a new way of copying things onto stuff. First of all, we're going to do connectivity, because we want each of these points to have their own class attribute, and it's on points. So first we're going to make a for each connected piece. And so it does make connectivity for you, but since I made it, whatever. Next we're going to have to go to the block end here of this for each. And then we need to do a few things. First we need to make sure that the piece elements are points, because we have the class attribute on point attributes instead of primitives. So we need merge each iteration, so that's good. But then we could just do auto detect from inputs here. And then another thing we need to do is we need to create a meta import node. And what we're going to do is going to look semi-complicated, but it's really not, especially once you see what usually is done in copy stamps. It's about the same thing. So we're going to do a transform, and then we're going to create a box. And so the box is what we're going to be transferring onto those points. So we're going to go here real quick. So this box, first we want to make it a polygon mesh, because we want to be able to manipulate the sides of it instead of just its corners. And I'm going to put in some values that I found that makes a good box shape first. I'm going to do size 0.1, 0.6, and 0.1. Next we're going to have to rotate this in the x-axis -90, so that it's lying down. And then we also want to change the center of it. So I'm going to put this at 0.3 in the z-axis. Oh, actually, I don't want this to be 1.6. I want it to be 0.6. And so then now that puts this perfectly at origin and facing in the positive z-axis, because when you copy things, it's always along the z. So now what I can do is I can connect this here. And so what this transform is going to do is it's going to change the thickness of this thing as we copy it onto different points. So we can do copy to points. so we can see up here, this is mostly doing what we need it to do, but we want to vary up the shape. So a way to do that is we can go to this transform, and over here we can create a spare input, and then we can take this here and drag it. And so if we click on this, we can see here detail attributes. So what this does is it creates a detail attribute of both iteration, numerations value, and I value. What we want is the iteration. And so the iteration is just basically a random seed that it creates on these points, saying, okay, I've brought in this point on, or this object onto this point, then I brought this object onto this point. And so that we know, it just gives us a value per object that's being brought in. And you can see this is working by this purple line here is going into the transform. And so again, we need iteration, and so the way to do this is that you hit tilde, which gives you this sort of backtick thing, and then you do detail, and then we are choosing this for each begin metadata 1, and then the detail attribute that we want is iteration. And then if it doesn't find anything, we just want it to be 0. Okay, so now that we have the spare input here, what we can do is that we can go to scale. And so I'm going to do fit01 rand channel, because it's going to go to the channel down here that I've created. And I just put in the string value of spare input 0. I can have it autocomplete, and then I want to change the seed of this so that they aren't all going to be exactly the same across each channel of scale, so X, Y, and Z. So now that I have this done, I can do, I found that 0.25 to 1. So now we can see that all of these are being affected. Well, they're not all being affected exactly the same, but they're all being pushed in. So what I can do is I can just copy what I have here. I'm going to go to Z. So now they're all being pushed in random different ways, and this one I'm going to say is 2, 3, 4. So that changes the seed up, and then we'll just do the same thing here. Make it all randomized, so 4, 5, 6, or 2, 5. For consistency, I'll make this 4. Okay, so now none of these are perfectly rectangular. They're all just being mixed up in different ways. And this is how you can copy to points and then change values in an iterative fashion on stuff rather than using a copy stamp. And you could do this as well if you wanted. You could say rotate. Let's say we want to rotate along Z. We could do that and then make this 0 and this 180. Now you can see that these are all randomly rotated. Might as well do that. Look, that looks pretty cool. And we just want to do it around the Z. We don't want to mess with the other rotation axis. Alright, so now that we have that, we have our shapes, we have our ice crystals, and you can see that they're much larger in the center than they are on the edge. But what I had done here, I didn't totally explain it, but here with the P scale and fitting it, I'm making sure that none of these get a scale of 0, because we want them all to be there. We just want to lock it at something like 0.6 and then make sure that in the center it's 1.5 times its normal size. So again, this is just locking it in, clamping the value to 0.6. Next, we're going to do a poly bevel. And so that's just going to give us interesting edges along these. I found a good value for distance is 0.005, which actually moves it a decent amount. And then next we want to add a bit of noise to these so they aren't perfect. And one thing I've found, and I think I'll just do it now, is I'm going to take this point VOP. We've already made our noise. It's simple noise. I personally have created my own tool for simple noise, but since you guys don't have that, I'm just going to be using the point VOP. We're just going to take this, we're going to copy it, we're going to paste it up here. We're going to get rid of this expression because not everything's going to have an offset driven by time. So now this is just going to sit up here, so anytime we want noise, we can just pop up here and then we can take noise. We don't have to dive through things and find various noises within our graphs. So I'm going to copy this now. I'm going to paste this here. So that's too much noise. So we're going to do something like an amplitude of 0.028. And we're going to increase the frequency to something like, let's see, I have it at 5.8. And something like that should be fine. It's not perfect because few things in nature are perfect, and so ice crystals, they won't have a perfect shape, but they will look very geometric, but we want to push things in, vary up the surface a bit, and I think that's doing exactly what we need. So next we're going to take points from volume, and again, I know what value this should be to fill these out and give us a shape with points, but you want to be careful, so I know this is going to be 0.0025. And if we middle mouse here, this is giving me close to 3.5 million points. And we don't want to go too much higher than that. 3.5 million's totally fine though. So we'll jitter that up. And now we have our points from volume, and we're going to make sure that they have a color of black. So technically what we could do now, if we merge these two things together just to get a quick idea of what it looks like. I'm just going to set this black just so that we can see them together. So we have everything that we need here to get the ice crystals. So if I were to do a VDB from VDB from particles. I'll just make this 0.01. Make a convert VDB. Make sure this is polygons, so then our voxel size is way too high, so we could do something like that. And so this is close. We probably still need more fidelity on this, but you can see that this is close to what we need. So if I made this maybe 0.075, yeah, that's closer. But this isn't exactly what we need, because what we need is we need these to first grow, and then we need to make sure that when they're growing that the VDB separates so that we have the ice as one object and the water as another object, and so eventually all of this will turn to ice, but there needs to be a blend between the two. So I'm going to get rid of this for now. So the way to do that is first we need to create some geo that's going to act as sort of our cutter that's going to grow out and then go into these shapes.